Hi, and welcome to this poster detailing mine and Tom Sambrook's investigation of parietal reward prediction errors. To make things easier to navigate, let's scribble all over it. So, as a basic principle within reinforcement learning, individuals strive to seek out rewards and avoid punishments. The method with which the brain codes such behaviour is through the use of reward prediction errors, or RPEs. These RPEs are calculated as simply the difference between expected outcome value and actual outcome value following decision-making behaviour. Now, two electrophysiological components, the frontal feedback-related negativity, or FRN, and the more parietal P3, have been implicated as potential RPE encoders due to their sensitivity to an outcome's valence, so whether it is good or bad, and an outcome's size, which, when interact, constitute an RPE. Despite these sensitivities, there is disagreement on whether the two components code RPEs due to inconsistent reporting of their latencies. This issue has since been addressed in the case of the FRN using great grand averaging, and so it was our job to use the same method in order to see if there is similar RPE encoding at parietal sites. So great grand averaging essentially disregards published effect sizes in favour of the direct quantification of published average waveforms. What results is a process that provides superior estimates of effect size when compared to conventional meta-analyses, as well as putting previously incomparable results of past research to further use. Now, as an RPE should be represented by an interaction of outcome valence and size, we collected waveforms fitting a 2x2 factorial design of both these variables. Here you can see the grand average waveforms for positive and negative outcomes at both frontal and parietal sites. As we'd expect, our waves are more negative for the negative valence outcomes. When we difference these waves, we can clearly see sensitivity to outcome valence, not only for our frontal waves, but for our parietal waves as well. Now, this effect was found not only to be significant at both sites, but at exclusively parietal sites around 420 milliseconds post-outcome. Crucially, we want there to be an interaction of both valence and size effects. And so by differencing the small and large difference waves, we can see any underlying RPE encoding. Once again, we have an expected RPE effect at frontal sites, but also an RPE effect at parietal sites. This effect is also significant in exclusively parietal sites around 380 milliseconds post-outcome. So ultimately, our analysis shows a second RPE encoding component that is parietally expressed at around 350 to 420 milliseconds post-outcome. This not only counters the claim that the P3 codes only for outcome size, but also presents a distinct, quantified time interval for parietal RPE encoding. Thanks for listening.